Yeah, the plan is start 30 past 1:30, but we are still gathering the people. Okay, good afternoon, AEC Hackathon. Good afternoon, everyone. We plan to start at 1:30, but we are still gathering the audience, the people. The teams are finishing their work, so we need few minutes. But I believe that we can start very, very soon our presentations and the final presentations of the solutions from this event and the results of the challenges. I have a question to you as a kind of the warm-up. Do you know why the dwarf is our hero here on AEC Hackathon? Probably you recognize that we have a dwarf in a hat as a hero. And do you know why? It is a question not to the people coming from Wrocław, because probably all you know. If somebody would like to explain. Ah, Lindsay, come on.
Is it a symbol of soft resistance to Russian occupation?
Yes, yes, exactly. It is a symbol related, linked to the previous political system in Poland, some actions against the government, but now we have over 600 small dwarfs around the city, a special application where the children can walk around the city, or parents with the children, and look for the dwarfs, over 600, and mark them in the application and to spend together the time. Interesting fact is that everyone can buy the dwarf for themselves to put it in front of the shop, the office, and so on. So I can imagine that next AEC Hackathon Wrocław Edition will have also a real dwarf in front of the buildings. That's great, that's great. Okay. Working. How do you feel today? Make some noise. Show me your energy, power, emotions. That's great. Thank you very much. I saw a lot of energy, a lot of positive emotions. Your motivation past the last 2 days, and yeah, I see that it is still with you. So thank you very much for this. I believe that all of you had a very productive and exciting time last 2 days, bringing your ideas to solve the problems, the real life problems we had. We described and we presented on Friday. And I'm really excited to see the result of your work. Now we are going to start the presentations from the teams who worked on the challenges to present the results. As a short information, each team will have 10 minutes to present their solution, and then we have 5 minutes for our jury team for Q&A session. After the presentation, coming from 7 teams, we have 7 teams, then jury will take time to consider, to discuss, to evaluate your projects. And then, when we have the results, we will present the results of the evaluation, and of course, announce the winners of our AEC Hackathon Wrocław Edition. I can say edition 2024, because I'm really sure that it is the first but not last edition of AEC Hackathon. Okay. One more thing before the presentation. Yes, I know that you are ready. Just before the presentation, let me introduce briefly our jury members, and please welcome Ania Rydzy from Building Smart Polska. Agnieszka Tatarczak from Arub Polska. And brothers jury, So Marcin Pszczółka from Beam Corner. And Dawid Fetko from Beam Meetup Polska. Okay, thank you very much. Thank you very much. You see some of them presenting Tech Talks yesterday. I mentioned that there was a chance to get some additional points. I believe you ask right questions to them. So let's start the presentation. Let me introduce the first team. I have to check because there are very strange names. As far as I remember, the team called In Progress. The stage is yours.
Hi, hello everyone. Great to meet you. Good morning. Our name is In Progress because we are tackling the progress in the construction. So we want to measure how fast and what is the progress in the construction. And there is also another reason why we call ourselves that way, because our solution is still in progress. So I think the name match our. Can you switch? So what's the main problem in the construction industry and measuring how far we are and like comparing it? So the first thing is very time consuming. It's based on the human checking each place. Sometimes people are going to site and do it manually. Sometimes someone is watching the images, but it's very based on human checking things. Another thing is like it's prone to mistakes because the humans, of course, they make mistakes when they are tired. Another thing is the finance, like human labor costs a lot, and it's going to cost more and more with the time, so we are trying to solve all the stuff with AI. And another thing, it's not alive, so you cannot check at the same moment what's the site progress. You need some time to process this information to be able to check. We are, I don't know, 50% to be finished. We have delay. And another thing is that it requires training of the people, so there are specific methods usually. We will show you how it was presented for us by Atlas. But you need the training, you need to follow certain steps, and it also requires time. I'm going to move my mic.
So in the task that we were kind of trying to figure out, we had located 360 photos and a beam model, and the idea was to, based on the photos, recognize if each element was built or not. So we tried 3 different solutions. The first one was related to generating synthetic data from the 3D model and comparing it with the 360 image. The second one was related with the image classification, just 360 image. And the third one was related to the point cloud.
So in a nutshell, we knew that we would like to use AI tools for image classification, segmentation, and so on. So we knew we had real 360 images from the building site, from the construction site. What we needed to generate is virtual ones, and then using the AI tools, compare them. And based on that decision, send the information back to the IFC model to report the progress. So first thing we found is that there is a web app where you can actually perform a segmentation on an image, and we knew that this model would work for our case because we decided to focus on columns, and you can see that they're selected, and each region would then be used as a mask to compare with images, with fake images. But how do we create a virtual 360?
As it is a key component to generate spherical images from the BIM model in the exact same position as we have the real spherical images, we tried different methods, and some of them didn't work. For example, we tried to load the IFC model into Blender and generate the spherical image there, but that kind of didn't work because the geometry didn't show in the way as we expected. So we tried different other methods. So we exported the IFC model to a WebGL model and took screenshots there and arranged them in a spherical image. And another, that kind of almost worked, but another method that actually worked was in Unreal. That's you again.
Yeah, so that is quite a known workflow. We imported the IFC file, like filtered, because it was quite big. Imported in Navis, then from Navis we could bring it into Unreal Engine, so that's a gaming industry solution, and it's known for automated way of performing certain tasks. So we wanted to automate virtual 360 image generation based on the real panoramas location on construction site. So the goal was to reconstruct real 360 real image. Virtual environment has the model data. Every column was then, can I ask for the next one? For every panorama, we focus on elements within a certain radius to minimize the search set. No, let's go back. Then we saved a series of images where basically every image represents the information, the mask about certain element, and the name contains the ID.
And when we had this, basically we tapped a bit more into the coding stuff and getting more into the AI models themselves. And we compared the masks that we have with the images, or like two types of masks, from the real images and from the images that were artificially created.
So then we used Power BI dashboard to communicate what happens in the model with a dashboard, and we used IFC OpenShell to add a parameter to an IFC model that would tell us if this element that we were looking for was built already or not.
So with the use of 360 segmented images, we were able to map those 360 segmented images on a sphere and then check intersections coming from the rays of the center of the lens. And therefore, we were able to kind of compare the 3D model of IFC with the segmented image.
So in the second method, that's probably the simplest and the easiest, but not the most accurate. We used image classification instead of segmentations, and one second, go back. And we only need two things for this, basically. So still the 360 image and number of items that are within certain radius that the image was taken, which is numerical value, so there is no comparison of masks of images or basically nothing like that. All right? And this is kind of a prototype that we kind of wanted to get to, but we tried to play with the model in different ways, basically. We tried to do the columns, but unfortunately, due to the limitations of the data set and the usage and all this kind of stuff, we succeeded with basically segmenting the people, and like you can see also a car in the background. So kind of another challenge, but yeah, that's the successful part, let's say. And if we had more time and a broader data set, we would surely got into the columns themselves.
But we also decided to check another approach, just to compare the data from the construction side and also from BIM model in 3D. So we had also the video from drone, which we could convert into point clouds. So having this point clouds geolocated, then we were able to check, okay, is this element from BIM model, does it have inside points from point clouds? If it does, it is constructed. If it doesn't, then it isn't. And we gave that information to IFC model later.
So the point cloud wasn't accurate enough, actually. So we decided, okay, what if we create then our own point cloud? It's this location here yesterday, that's my iPhone, and you can see we were able to scan, like this technology is evolving so fast right now. So with the iPhone, you can solve it much easier. You don't need to compare the images. You can just scan whole space in much less time. Because like with the previous solution, you need some person every time in the same space, do the 360, and then also put it on the model, put where there was made. There was a lot of additional input. With the point cloud, you can omit all this input and just make the camera on the helmet, connect with your app, and gather this point cloud from the workers while they're working even. So this is something which we obtained from the iPhone. Like the point cloud is very accurate. It's like the spacing, it's also accurate. So we can see the pink one, it's like the elements of the columns, which are inside the, say, in the void of the IFC model, and how we compared them. So we didn't check the points inside the volume because it's like also time consuming for a big point cloud. We more checked like XYZ location and how many of the point cloud we will have if we just project the number of the point cloud distance on this column. So then if the point cloud in this area have like 50%, let's say, of all points, this means there is some elements there. So I think this is a simpler solution, and it will work not only for columns, it will work for all the other elements. And we also believe this is a better solution than using 360 images, because this is also how the industry is trying to solve it. This is a big problem, very wide now in all construction. There are a lot of startups which are trying to solve exactly this problem with a big funding, and they actually trying it with the 3D point cloud. So we think 360, maybe it's not the best way because it still requires a lot of labor. So this is our team. We had a lot of fun. There was a great team spirit. We spent a long night yesterday, and yeah, and it was amazing. I was a bit scared coming here, to be honest, and now I'm not. It was really great. So thank you so much.
Thank you very much. Thank you. Very impressive. And now we are waiting for another team. Congrats, congrats. Great. And up next, we have a team called... sorry. Yeah. Sorry. No, not so fast. The question, Q&A session, and the voices on the jury table.
Okay, so my question is about how you check the collisions between point clouds and 3D models. So it was in Navisworks, or you use some other solutions, and how you connect the data from those collisions to the IFC model.
With the point cloud or with?
Yeah, with point cloud and 3D model.
Yeah. So we extracted we didn't really use the 3D as the voids or whatever. We extracted the vectors from it more. So we did all this operation in Python, which has like open 3D for the point cloud stuff. So not using the softwares, because it's not a scalable solution. With a big point cloud, it will never work. The point clouds are so heavy. So yeah, so we were more operating on XYZ coordinates.
I have a question about the photo processing. So you mentioned that one of the disadvantages is that you have to always take a photo from the same place to catch the surroundings. So I want to ask how many benchmarks you have to provide on construction site to be sure that you actually catch the whole construction.
We decided on the radius. We divided all the things. We measure what's the radius. And it was the data we got from Atlas, they were like very, not regular. Yeah, so like with the radius, I think it was 30 meters, we were able to cover all the space. So we did like radius around each space, and we tried on which radius is kind of fitting to cover all.
But you had also to provide the origin to the model, that always you have to stick to this point, yes?
Yeah, with images, one thing that also we didn't mention, but there was a kind of a wall that we hit at some point, because the images were obviously high resolution, the 360 images, but for the processing, for the model itself, we needed to downscale them. So, for example, like columns are, let's say, easy enough because they are big and they are quite distinct on the, like compared to the rest of the environment. But for example, if we increase the radius and the columns in the backgrounds are getting smaller and smaller and smaller, it would be harder for the model to segment or classify them. And also, this is the case why it's not the best solution for smaller elements, like some kind of piping system or, yeah, things like that.
I can add something to that. With the spherical images, we can take actually a subset of the IFC model by filtering out everything what's not in a certain radius. And then we generate the artificial spherical image. And we can take one element in the IFC model and make it blue and everything else white. And by that method, we have the GeoID of that model, and we can generate as many spherical images as we want. And then we can overlay that with the real spherical image by segmentation. And then we know exactly which element we already have. And then we have a list of all elements that so one by one, we make one blue or red, and the other one, we leave them white, for example. And we can go one by one through all elements until we have everything which is in that radius. And so we have a list of all elements of the complete model, and we do that for every spherical images until we have completed the complete list which is in the IFC model.
Yeah, last thing to add is that our model, the models we were using for image processes were not built for our industry, so the closest we could get is the person in the car. There was another model we were trying to get which would help us classify columns perhaps as street lamps, but the big challenge for our industry is to train the model which would deal with the classes of objects that we are interested in.
Yay. We are still waiting for authorization.
Yeah, still waiting for the data set. And even if there are some data sets, they were super specific. For example, like cracks in concrete walls or something like that. So there is not enough data to work with for now. And yeah, that was one of the biggest problems for us, I think, at some point.
So last question, because probably as you mentioned, for registration on a construction site, you need to use combination of point clouds for like columns and also for electrical sockets photos, because you cannot extract this from the point cloud. But I also thinking, how did you consider a process of collecting this on a construction site in a case of collecting data about subcontractors, for example, who poured this concrete and so on, or only dates and classification of elements?
Is that about the date?
I'm not sure if we understand the
Okay,
question
so,
well, but I think the task was more to the progress, so we didn't tackle like the problem like, oh, this is by this contractor, this is by other. It was like the task was defined as the progress of construction.
Maybe if you would give us another hour.
Okay, so thank you. Very good presentation and work.
Thank you.
Come on, picture. Maybe closer to the edge. Yeah. Thank you very much. The next team, the team called Bobber. Bobber? Okay, one. Team called Bobber. Okay, please, come on. Próbujecie się podłączyć? Chodźcie szybciutko. Somewhere.
Thank you. So in the meantime, I would like to thank you all for coming here. Like, I'm super happy that this event even happened. Okay, now we can start. So I welcome you on the short presentation by Bobber team on how we would tackle the problem of urban heat island. As you can see, we tried to take advantage of so many wonderful people that are here in a way that all people in our team show different abilities and different interests. So we wanted to use it and divided ourselves into different sub-teams. And we wanted to also divide this big problem into two smaller ones. So the first one is what is the heat island and why we even care, and how to raise awareness between citizens so they also care. And the second one is how we can actually start solving urban heat island. And of course, we will start with the first one right now.
So I want to introduce you the topic. What actually is urban heat island? It is a problem causing the cities. The temperature in the cities is getting hotter and hotter. And there are several different factors causing this problem. One of them is albedo effects. It is connected to the reflectivity of the surface. Second one is a canyon effect. It is connected to tall and dense buildings, and it is making the streets like a big canyons. And the third one is lack of vegetation. Cities has less natural cooling through the shadow. And because of this problem, there are several consequences, such as heat-related illnesses, increased energy consumption, and worse air quality. These problems are very important not only for humans, but also for the environment.
So I hope we now expressed why this topic is important, because it's not ecological, neither functional for people. Now we want to tackle this next step, is why civilians and people living in cities should even care, and if they want to care, how they can know what is it about and what to do about it. That's why we wanted to create a website, and you can scan this QR code, but please remember that you need to be connected to the same Wi-Fi as we are. On this website, you can see our simple application that will show what are the problems of urban heat island. We expressed the problems we talked a moment ago, and why is it important, why we should care. But also, we included MVP of a heat map, where the citizens could see where this phenomenon is happening the most, and understand how is it influencing their everyday lives. So the next time you're going through a plaza and it's generally cold in the city, but on this particular plaza you feel like on the plate or in the microwave, you can check if this phenomenon is corresponding to your feelings. But that's not the only thing that we have actually done, because we have also wanted to start to solve this problem, or take a small step to solve it. So we wanted designers and urbanists and authorities to know how their designs and how their actions will influence urban heat island. So we have created a tool, or rather MVP of a tool, where you can could input buildings or trees, a park, to check how this would influence the urban heat island in the future. Right now, the algorithm is quite simple. It takes a point, a coordinate on the map, checks the what temperature there is right now, how is it shadowed, and so on. And in such a way, it could output a new map to show the effects of the design.
Okay, and I'm honored to present our technical solution, the technical part. So what have we implemented? We have the client side, which is you, and we are making the HTTP request to the front presentation layer. This was written by us on the JavaScript. After that, we have the API and the backend business and backend data layer. On the business layer, we're transformating and manipulation of the data. In the backend layer, we are able to access the databases, which we created for the demo presentation, this MVP on the MySQL, and also the third-party services, which are also communicated via HTTP requests. And there is the response, and here what you have on your phone. And this is what we have implemented, but also we had the second solution, like the second plan to implement. It is cloud-based solution because we thought about the xeokit cloud and maybe the future of our solution, what we can do. So it is not only the website. It can be treated as a plugin, as an external plugin, for example, for the Rhinoceros, for Blender, for SketchUp, or many others. Yeah, and from the app, up in the diagram, we have the DNS name, DNS server, the content delivery network, and load balancers, everything what is needed to be to run securely in the cloud. Also, we're thinking about the divide our solution into the subnet, and for the high scalability and reliability, use the two machines, also the two databases. And what is like the most important for the solution, we can simply connect to AI models. And these models can help us in just help our algorithm to be better. For backup purposes, we predict that it will be on the S3 bucket. On the right side, we have the third-party sources. We are not limited to anything. We can use wherever we want. We just put there the geoportal, and OpenStreetMap, etc. Yeah, and I think that this will be it about the...
Okay, thank you. So as you can see, we have created a really simple solution right now, and it's more to mock up and to show the idea what could have been done with a little bit more time, let's say. But we also wanted to mention what would be the next steps. So if we would manage to finish this algorithm of calculation, what would be the hit island after some changes by designer? Theoretically, we could also use the optimization algorithm to check where would be the best place in a city to, for example, create a new park. So such an algorithm would show the designers or authorities where in the city is the best place for a park or a building or whatever to make the hit island less and less visible. So this would be the next steps. Unfortunately, there were some problems with, of course, data sources, as with the previous group, and a little bit tiny amount of time. But of course, this was an amazing journey. So to sum up, I wanted to mention that this urban heat island problem is a really long problem, but we had a lot of fun researching it and trying to understand it. And of course, creating such a simple solution, or rather thinking about how this solution could have been made. So thank you for listening, and if there are any questions, let us know.
So, great presentation. I would like to just ask one question about the data source, and what do you think, what kind of information you have to provide to be able to conduct this UHI analysis? What do you need to conduct?
Sure, so right now we have some maps of temperature in the cities and urban heat islands, but unfortunately they were not so easy to use with our APIs and to include in our application because of different data formats and so on. So the data is actually already there on the temperature in the city that we would probably love to change a little bit the connection with this data. Apart from that, we should also have information, for example, about the shadows that the buildings are created, but this is something that we can have because we have the 3D models of most of the cities in some way. So we can calculate the shadows, so it's also there. So temperature shadows are already there. We have also thought about including wind, but this was actually the most difficult thing to include as we would need a lot of simulations to actually understand it. Are there any? Oh yeah, we also needed information about surface, and simple information about surface can be found on OpenStreetMaps and any other maps and links that we were provided. Nevertheless, they were not always as specific as we would love them to be to calculate this in more detail. And the most important thing about the data, I think, is that it would be really useful if there would be any research trying to calculate, trying to figure out this exact formula for how each factor influences the urban heat island, because this formula was a huge question for us and we spent a lot of time trying to figure it out. Nevertheless, in such a time and without more data, we were not able to do this in any detailed way. So that would be great.
But do you also consider that, for example, material type can influence your heat map?
So, yeah, the basic problem we had right now is that you want to validate your formula, right? We could get a lot of information. You could possibly also, there are some projects that are trying to get like from Google Street View to actually automatically figure out the albedo of a facade or see how many trees there are. All of that would be doable. We could get all this information. We have the shadows that we could calculate. We kind of know the ground cover more or less. But then we want to compare this with actual temperatures. And there's pretty much the temperatures from one weather station here in the city center and another weather station at the airport. So obviously we do not have enough real temperature values to actually compare. Is it true that this is 2 degrees hotter than the rest? So I guess you would have to do like a bit of a pilot project and have actual thermometers somewhere in specific areas and use these specific ones to then recalculate all your formula and see which of these values of all this data would actually make a difference or not, and then apply this to the rest of places. But without these values of temperature, we're just making assumptions at this point.
Terrific presentation. Congratulations. So in the presentation, you've mentioned plugging AI models, and I'm still wondering, would this tool be doing the actual calculations, or would it be doing more like predictions?
Well, yeah, that's kind of the thing. You use AI, you use statistics to improve your model, which is then doing the calculations, and then in the end you would have these calculations which are kind of telling you this area is probably going to have less of a problem than others. So the AI would be for training the model, I would assume. Or
Okay, so no other questions, I see. Okay, so thank you very much for your attention.
Please come with me here and we will take a picture together. Thank you for such an interesting presentation. Now the picture of our team. Thank you very much. Okay, let me invite the team number 3. EasyBTF, please, welcome.
Take the mic. Fantastic. Setup. Fantastic picture. fantastic. The shot is the picture, right? Okay. So we're going to start our presentation with a small group picture. We're going to first? Okay. Fantastic. Okay, we'll do it a little bit later. But we have a smaller team as the previous two teams. Smaller problem to solve and a smaller solution. So basically we're tackling the problem of generating BCFs and simplifying model-based communication. So first, what is this BCF? What is this abbreviation? For the people that are a little bit involved in BIM might have heard of it already. It's basically like a file format for model-based communication with the idea that it's easier to exchange issues and problems in a design model between different parties that are using different softwares. So basically a BCF is like a small tag, a small ticket with a problem. And every in a software you have like this like list of issues with these topics, and if you double click on it, it zooms on the specific problem. So let's say there's something wrong with a column, your architectural model is having a clash with the MEP model, you can create a ticket out of it and it zooms to that specific position, and it's also an anchor point for further discussion over comments to together solve this issue with way less communication, to avoid lots of email traffic and do it directly based in the 3D. So it's been around for quite some time and it's already working in like lots of larger BIM projects. The challenge that we saw also in our everyday practice, it needs like a little bit of a technicality to get it going. You need to be like in one of the 3D softwares. You need to like have a BCF manager installed. You need to know what a BCF is. Perhaps you need to communicate to some kind of central server where it's stored. Sounds everything very technical, but most of the people who need to judge like a design are people who have less of the technicality. So they're decision makers, they're the project leaders, perhaps like board of directors. And we noticed that there is still a gap in like the people that need to use the technology and actually how easy the technology is to use. So the approach that we had, like in this very small time span, is okay, how can we streamline this and to the absolute minimum. So we had the idea of just creating BCFs based on a simple phone camera picture, perhaps a small comment in a chat or an email, one line, maximum 5 words. And it's creating automatically a BCF. That's the first anchor point to start a later conversation for the rest of the team to actually solve the problem that's been triggered by the project leader. So we're gonna start off with the small demonstration. So the chat app to simulate this that we use is Telegram. The idea is that we can implement it later also in Microsoft Teams, Outlook, all kinds of chat tools that are already in use in the everyday practice. You can create a small picture, like you're on the construction site, you see that the balcony has been made incorrectly. You're messaging the team, hey, what's going on with this? Can we please move this? And then we're sending it off. So in the background, what's running in Telegram, it's quite easy to create Telegram bots, so that's what we use for this demo. If we do like the @BCF, it's telling the bot, okay, we need to do something with it. It's parsing this image and the text in like a very small pre-trained ChatGPT model, and it's outputting like a very simple file-based BCF according to the BCF version 3 to the building smart standards that we can, for now, import manually into a communication platform. So the communication platform that we see here is BIM Collab Zoom. It's quite well known and well used for teams that are using this technology in the cloud. Exactly. This is the BCF that was just created over the Telegram, and now we're uploading it. We're planning, like, yesterday was a very short time span. We were planning to, like, do this automatically. There's, like, a nice SDK in the background, so, like, instead of just manually drag and drop, the idea is that it automatically uploads. And this is the picture that was just taken. The topic is, like, the AEC Hack, because we're in the AEC Hack today. And it's a bit pixelated here, but this is the comment that we've just written down. So this is the first proof of concept that's...
One word of correction. This is actually not the comment that was written down in the app. It's an AI interpretation of the comment, because the main clue was to kind of translate the non-technical feedback into more actionable feedback for the technical people to implement in the design.
Exactly. So yeah, that's our small proof of concept, and we were like brainstorming today, what can we do with this? You know, the first thing we were thinking about is, you know, removing like all this manual uploading, make it like a full automated sequence, and we're also very interested in the idea to make it like some kind of package that can be integrated, you know, as a Python package in lots of different kind of softwares, perhaps to integrate like Microsoft Teams, Outlook, perhaps Grasshopper, all kinds of different chat applications that are in use. And perhaps connected to like some kind of AI meeting summarize software. So yeah, that might be the idea for the next hackathon. Thank you for listening.
Okay, so my question is, because here you have, can you hear me well? Okay. Here you have a chat, and how you extract the specific topics or threads, because in a BCF you should have other topics in the different threads, yeah?
Yep, actually, exactly. So this is what we use the AI for, so that it takes the message, the non-technical message, and it tries to infer the topic. It tries to infer the description and the comment.
Okay, so I assume this is the entry point for a BCF communication, and then you need to switch to the platform, for example, for close the issue, yeah?
Sorry, again?
To close the issue or put a status there, you need to do this in a Beam collab, yeah?
I mean, the possibilities are endless. This is what we have is only the MVP. What someone does with it later is only one's imagination. I mean, if the API is exposed to manage the BCFs from the chat, it can also be implemented, yes.
Thank you very much.
This is brilliant. Congrats. One thing I'm wondering about is that if there is the interpreter behind this, then later somebody will go into Beam Collab and say, I didn't say that because the AI has misinterpreted this. You've probably thought about it, but I was wondering, what are your thoughts on this? Whether, you know, it just changes the meaning.
Yep. Well, there is always possibility of that happening. As a workaround, there can always be a database with the raw input and the translation, the AI translation, so that if there is a situation, I didn't say that, you know, people can go and investigate in the database and check what has actually been said and if the translation makes sense.
I mean, one of the ideas we're also thinking about is like just having like the original quote on the top of the comment, and then underneath like automated interpretation, and then have the automated text to clarify what is the original message and what is like free AI mind that can be very inaccurate.
Just one remark. I will propose the explanation of the acronym BCF to Building Smart International. I think that it's better than now.
Also, in a current solution, if you want to interact with the sender, if you already sent a message through Telegram, but now I would like to reply, how can I do that?
Oh, yeah, so initially how it was set up is that it was the one-on-one with the bot, but I changed it yesterday evening so that the bot is actually a member of the group. So there can be multiple members in the group. They can discuss different topics, and when someone puts this add BCF in their message, the bot will read that message as the input for the BCF. So many people can be the members of the group with the bot also as a member, and yeah, that way we can have multiple people chatting.
But today you have to actually send BCF again to actually read the message, or you have this thing already established between the...
Oh, so the bot is running, the group is there. Well, at this time only I'm the member. We can always have a boy join, and you will see that it still works. I mean, can you join the group?
I don't know if we can manage that in time now.
Yeah, sure. Live demo, it's Q&A already.
Let's see if it fits the time. This is unscripted and improvised.
Totally unscripted, yes. As a QR, scan this.
And now I have to send at BCF, is that the idea?
Yes, but first maybe connect your phone so that we can see your screen. And then also the HDMI to this. Yeah, it's a bit...
Does it show something?
Not yet, no.
Is it even going to show something? I don't know if my phone even accepts it. I don't think we get the phone now.
Then maybe I will show my screen of you texting in the group.
Mm-hmm.
So this is unscripted. As we see, the boy has joined. Now he's typing something. He will send the image with the caption with add BCF in the caption, and hopefully the BCF will be created. We'll just have to upload this again because the upload process is unfortunately still manual. We didn't have enough time or members to do it.
Let's see if it works.
The script says it was a success.
Ah.
Take a picture.
Yeah, great. In the middle, what would you prefer? Yeah.
Thank you very much. Thank you very much. Thank you. Next, fourth presentation will be managed by Team 5. Please welcome Team 5. The stage is yours, guys. will present. Marcin?
Thank you. Hi, we are team number 5. Talk to me, BIM. Come on, guys. Okay. So our solution is a user-friendly natural language interface integrated with an online BIM viewer that allows architects, engineers, and site managers to interact with BIM models through natural language. And with this solution, users can ask specific questions and get detailed insights and reports directly from the model without requiring advanced BIM tools. So on the right here, we've got some examples of some of the prompts that a user can make of the AI. So the way it works is basically upload your model, and we're using XeoVision viewer here. And so the model gets stored in the exascale object storage database, and then from there you can just start asking questions and get answers in the form of visual and textual feedback. So here's the tech stack we're using, implemented in TypeScript, using Nuxt.js, Vue.js for front end, OpenAI for back end, and xeokit SDK for visualization, and Bun for build management. Marcin will now demonstrate.
Okay, so what we do is we upload the model to the XeoVision simply to have the storage space for the model, and we copy the URL for the project. We paste it inside. This is like pre-loaded model, but we can change it anyone. And then the models are being read through XeoVision API. And now we have this 3D model, 3D IFC model on the scene here using xeokit. And here we can type our prompts. So so what is the biggest wall? Or maybe I will make it bigger. Oh no, it won't work like it. Oh, maybe. Here. Yeah. So yeah, and here we have the response. And what we do is we, on the first attempt, we generate the vector database. We fill out the vector database with all of the information from the IFC model, and then we also calculate other keys in the object, like surface and metrics of the elements. Then we can ask furthermore. So we could ask what is the weight of this wall? Okay, so the AI model responded that that the data provided does not include the specific information about the weight of the walls, but we can add mass. We can add information about what was it? that the density of concrete is 2.4 gram per centimeter. Well, the model knows that the concrete is about 2.4, but we can specify that the material is different, and we can give more information. So here with the surface and the height, and here so the weight is 218 kilograms, and we can tell the model to give this data as table. So this is kind of like, yeah, we can output it in table. We can output it as CSV. We will furthermore, we could even render the images of certain views of the model. So yeah, here you can see that this is live app. Here I have this quadrant database running. I have the script of our Next.js app. So we split it in the front end and back end, and we have a working API with to integrate other tools. And yep, so this is the first app. And we also have a second app, which we didn't have time to merge together. So with the second app, you load the same model. Here's an example, and here we didn't merge it yet. So so here you select something, and then you can let the app integrate with the viewers. So we can type to isolate the object. So it removes everything, but leave just this part of the model. And let's inspect the most relevant object properties. So here are the properties we get from the model itself, and some calculated values like estimated width, depth, height, and we can ask any questions about this data. So the source is publicly available on the GitHub, and yeah, that's it. So
I have a question about prompting.
Yep.
So is it like you can ask whatever you want, or you had to provide kind of limited number of prompts?
What do you mean by number of prompts?
Like you ask, for example, what is the size of this wall? Can I ask, for example, whatever I want? Like, what is the density of this wall? Or
Yeah.
Okay, so this is actually intelligent.
The density of this. So yeah, it said that the brick block, which typically has a density range, for example, density of the brick can vary from about 1,600 to 2,400 kilograms per square meter. So we could, yeah, we need to provide the mass of the material. So like in the first app, we needed to add the material. But if we could set all of the needed information up front in the system for the AI to know. So the like some agent could fill it out while adding the model to the app. Yeah.
Congratulations. One thing I'm wondering is that it would be super useful to use this sort of thing for comparing models. And that could be a next step, right? To build in, to load two models, two versions of the same model, and ask it for differences between these models. Would that be possible?
Yeah. Well, future for in the like next like improved versions, why not? This is like it is working only with the model which is loaded here. But with ZeoVision, with the xeokit approach, we can load many models on the scene, and yeah, it could work like that.
Okay, so if we did that, let's imagine that we have two versions of the same model, but in between these two models, someone just deleted a wall and instead created a new wall, so the ID changes, but basically it is the same wall with, let's say, just the different opening. So would AI understand that it's basically the same element, or does it map to IDs, or does it map to location?
Yeah, we generate the embeddings and we map it to the ID of this element. So,
but do you think there could be a workaround?
We didn't think it in that certain problem, but yeah, with more time. Why not? I think it could be possible.
Thank you.
Maybe somehow you could use XWZ coordinates to compare those, for example, wall. But my question is, did you manage to create interaction between chat and 3D models? So, for example, if you look for a biggest wall, you can display this in a first app, I mean.
I didn't get it.
Actions, how we use the command and a mediator that fires different actions so that it identifies us using a script, using strings to identify the actions.
Oh yeah, so with this second app, yeah, we can predefine the like actions. So here is the example of like simply removing to isolate the object from the model. So we could add any number of more actions and simply let know the AI on how to use the xeokit SDK to simply view or X-ray that or hide or change the color or yeah.
You are part of this category for humans, yeah? Done for humans. In your opinion, who should be the most interested to using this tool?
Who should be impressed? Sorry, could you repeat?
Who? What people? What stakeholders of the construction process can have a lot from this tool?
Crane driver. Crane driver.
Oh yeah, like a crane driver. So maybe like non-really technical users could open the model and simply ask in plain English or Polish. So you can ask the question in whichever language you like. So this is not only in English and yeah.
Okay, so thank you. This is all questions from us. Very good presentation. Thank you.
Thank you.
Let's have a picture in the middle somewhere here. Thank you very much. Please stand here in the middle. Closer to the edge. Come on. Thank you. Next presentation. I have a small cheat here, but I'm not sure if the name is proper. Placeholder name? Yes, yes, yes. I thought that it is placeholder, but it is the name. Great. Please welcome. Sure. Should I keep the microphone? Who will present? Jeszcze raz? Dobrze. Generalnie mamy pilota i ewentualnie można pilotem sobie klikać, tylko trzeba się podłączyć z tym, z Jinxem, jeżeli chcecie przełączać sobie. Przerzuć sobie proszę wariata i powinien działać pilot do prezentacji. Nie? Proszę? Poczekaj chwilę, bo musi się załączyć, wiesz? Teoretycznie powinien zaraz automatycznie zadziałać. Proszę mikrofon, przekazujecie sobie.
Przekazujemy sobie? Dobra, działa.
Działa?
Działa, dobra.
Powodzenia.
Tylko troszeczkę za szybko. Okay.
Hi, so placeholder name was our original name for this challenge, but I guess that we could call ourselves now IFC data miners, because like you will see if it will be a proper match. This is our team. We are almost all here. We all have backgrounds in IAC. We are developers, designers, and generally BIM people. For this challenge, we like the idea to simplify BIM for everyone, make it accessible for every single user. And as we all know, construction is a very complicated process, and very often we have a problem to extract information we need. We have a lot of people. We have designers who are sometimes working separately. We have general contractor and a lot of subcontractors who are like very often not aware of all of the process of all of the building. So yeah, and in theory we are depending on BIM models nowadays. But they are like data is sometimes hard to like. It's not very accessible for everyone, not for every single worker, and they are still highly dependent on other sources of information, and sometimes they cannot really find what they need to apply stuff at the site. So this is a sample process of this single worker on the construction site. So there is information created by the designers, then it's in general contractors, then it's in this subcontractor's hands. We have this single person, and they are missing some information. They need to do something. The time is passing by. So if they need some specific information, they need to go back to general contractor, then maybe to designer. There are many workflows, but generally time is passing by, and we have a lot of other processes happening at the background parallelly, and yeah, so it's very time consuming. We are losing some money and so on. What we try to do, and we are going to present it soon, how to simplify the process and to enable this person who just know a part of the project to extract information directly from the model. So the source of data should be IFC file. And for this specific project, we make assumptions that we have all the information inside. So this is a good quality of information, nothing is missing, it is properly classified and so on. And the solution will be presented by the colleague.
So, hello everyone. I would say that the main problem is that currently
the source of data is from the designers. And yeah, sometimes we know what are the needs of the construction workers, but we are mainly assuming that. And our main goal was just to think a little more about the workers, about their needs, and empower them, give them some superpowers, some new BIM viewer tooling, which will enhance their possibilities to solve their daily problems without picking a phone and calling to the design office that something is missing on the drawing. Because they should be able to get the correct data directly from the IFC without this pre-step like usually we are doing currently. So we tried, and we are very happy about the xeokit SDK. It was our first time when we were exposed to the technology. It's very, very blazing fast viewer for the web geometry file, which is providing us the possibility to provide the information on the construction site almost live. So let's see how, what are the main problems about different scopes, different contexts of the construction site. That we don't know exactly what will be the order of installation. We don't know exactly what extra data, what metadata is needed at the different sites. So we want to postpone the decision about the needed data as long as possible, to just provide it just in time on the construction site, without all of those quantity takeoffs, all of those drawings created much before. It should be generated on fly when it is needed. Because, as you can see on that project matrix, there are numerous of different factors on the construction site. So providing all of the data upfront will always conduct with a problem about the outdated drawings, outdated tables. So usually construction workers, they have very specific tasks. They need to install some pipe. They need to provide some new equipment on the construction. So they don't think about the whole construction as us designers usually do. Their scope is much smaller. So let's try to give them, let's provide them the tool which will be able to find the answer for their day-to-day problems without overheading about the whole model. So that is why we have developed the demo application where we are just saying who we are, what we are trying to do. Here, yeah, we are just saying that we are the plumber. We will be today working on the second floor, and please tell me more about that space. What should I pick to do it correctly? And if you think that almost all of the data, it is or it can be currently placed in the IFC models. But of course, sometimes it is missing because we always need to find time for the normal duties like creating the standard bill of materials. So the main goal is to emphasize the role of the IFC in the post-process. And as you can see, based on the xeokit SDK, we can generate the automatic drawings on the construction exactly for the need of a specific worker. We have not checked, but we just think that it could be also done on a tablet, on the iPads. So, you know, the construction worker can just click something what is interested in his current duty, get all of the needed quantity takeoffs, get the dimensions generated particularly for that need. This is the biggest change, because when we are creating the drawing during the design, we don't know exactly who and when we will consume it. So we are just assuming that, okay, probably this will be needed, this will be needed, this will be needed. But the whole purpose is to shift the process, to not do a lot of work upfront, but provide it just in time. And yeah, we hope that at the end, the final solution will make not only construction workers happier, but also the designers. Because we usually don't like that phase of the project, where every hard, logical things are already established. We just need to, you know, provide the same data in a little different format, which we all think is outdated. But the needs of the construction site are very strict, are very concrete. So yeah, let's just think about the better tooling which will help them to extract the data from our IFC models. And as you can imagine, it should not only provide the accurate information, because the construction will be not based on something which was created a few months before, but it will be provided on the currently updated IFC model. And we put, as an industry, a lot of emphasis on providing the quality of IFC, of making them available for almost everyone. So let's think also about the construction side and about their needs. And of course, as you can imagine, based on the data gathered in the IFC, we could think on other solutions, like we are usually doing now in the beam authoring softwares. I really like the presentation from Agnieszka and Kamil about those positioning of marks for those wind turbine foundations. And of course, the question is why the designer should spend time on that particular part. His work is already done. He calculated, he provided the structural estimation, and that's all. Why we are thinking about the representation. And of course, we are doing that because the rest of the process doesn't have the proper tool to do it themselves. So yeah, why not to take quantity takeoffs based on the IFC? I know it's not very innovative. It's currently in some softwares, but yeah, let's try to put those workers, their needs in the center about that kind of a development. And yeah, there are also some rebars. So let's provide the necessary details about the rebars for our bridges, for our constructions, based on the IFC. Let's provide the bending list, let's provide the drawings. Why not? That information is already there. And yeah, maybe it could also be used with something with what you have shown, with those very nice bot telegram, about sending BCFs based on the real struggles on the construction site. That the worker is taking the automatic measurement based on the IFC. He tries to do the same in real life, and hey, whoa, something is not working. So let's try to use your chatbot to generate automatically BCF, and we will have that. Yeah, and I just, when we were developing the tool, I just remembered my journey to planning of the kitchen. And you always need to, at first, think about some stuff and then take dimensions. So this, taking the typical building dimensions life is not only applicable to our industry, but also to almost everyone who is dealing with the normal physical world. And we are pretty sure that you also have a lot of different ideas how it could evolve, because the need is real. We are struggling with the current flow. We would like to only work in Grasshopper, in Dynamo, to only think about the parametric design. But unfortunately, in scope of our duties, there are also those ugly drawings and quantity takeoffs. So let's think how the next generation of the BIM tools could incorporate the needs of the construction site. And yeah, thank you very much. Thank you for this event. I would say that it's very impressive, that both for the organizer and both for you, that we all, when we were talking about going here, we felt a little afraid because, wow, what we will be doing, a lot, not so much time, and yeah, it's hard. So it's good to see that almost all of us, we survived, we are alive, and yeah, I think that now time just for questions.
A great presentation. I have just one question. Do you consider this this app as a standalone or as an add-on to existing tools that we have already on the market?
Yeah. This is based on the xeokit SDK, one of the web viewers for the IFC files. And now it's just an add-on written in a JavaScript, but to make it accessible, we need the very, very fast engine to do those kind of calculations live, especially for larger models. So it can be applied to other tools, but you need to have a proper engine to do that kind of stuff.
It's not a question, but a comment, because it's hugely impressive, and of course, 5 points for praising our presentation. So we're going to drawing-less construction now in some countries in Scandinavia, and that's your proposal and your tool could be so useful to just get rid of the drawings. So yes, well done. No more questions? Thanks a lot.
Okay.
Great presentation. Let's take a picture together. Where is the photographer? Yeah. Thank you very much. Really impressive presentation. Thank you. Good luck. Okay. Last two presentation in front of us. So please welcome the Pipers team. Come on, come on. All waiting for your presentation, guys. Who has the laptop? Would like to plug in? Guys, the microphone. The stage is yours.
Oops. So, maybe starting. Hello, everyone, and as well as all the other teams, we're really glad that we are here and that we could meet all of you in person and participate in such event. So yeah, maybe go back a little bit. Okay, so never mind. One of our main goals, a big part of our decision making was to analyze the workflow. All of us has different histories, different toolkits, and we want to have it quite how do you say it, elastic, I would say, for different interfaces. So most of our tools are REST APIs combined together. So the inputs could be anything, but we of course used xeokit for visualizations, as well as the outputs could be parsed into any program. We want to be, of course, independent in environments. So as well, so getting to the slide, we want to be, the idea was to have an engineer project rather than theoretical project. So we have real data, real IFC data that is passed to the IFC. We getting the bounding boxes, but of course we could get much more data from the IFC. Possibilities for complex meshes, as well as different types, properties, and we also could consider every element as penetrable, not only 0 and 1s, but almost like percentage. And of course, yeah, that's what I say. And then we could have also extract from IFC model and voxel data with all the possible weights. Yeah, and here are examples of the detected obstacles in xeokit.
We try also a different approach using a Rhino grasshopper. We have a short video that we see the obstacle, defining obstacle, the restrained possible pipe roads. The first step, we creating mesh structures and converting them into lines. Potential pipe roads, then converting Rhino grasshopper geometry into graphs. We're using Mega Arachne plugin developed by Wojciech Radaczyński. Then we specifying the initial and the first point of path and finding the short path using A-star algorithm. And that's all.
I was also focusing mainly on the algorithm. During the research for the subject, I have found this paper, weighted octree-based 3D indoor path finding for multiple locomotion types. It was quite interesting because we as humans and also pipes, when we are moving around the building, we have our limitations, we have our preferences, and this paper was trying to solve it. What I did is I implemented this paper using Python. I have set up a Python model with a server that would integrate with what my colleagues have done. And what this algorithm does is not only is finding the shortest path, but it's also trying to find a preferenced path. So for example, here we have found it 2 paths, but one, the preference height is 10 meters. And on the second, I have lowered the preference for the path. And as you can see, we have different results. And probably this algorithm could be developed, and we could find some other points of interest or other objects that we could snap to. And I think this is the way for the algorithm to go.
Okay, so we also focus on user experience quite much, because we didn't only work on several problems, but as my colleague said at the beginning, we wanted to cover the whole workflow from importing of the IFC to assisting the designer in piping design process. So here we have a small visualization how the points can be chosen, between which we will look for the path. Because as we assumed at the beginning, pathfinding algorithms is nothing very new. We have some sophisticated algorithms, of course, but that is not everything we need, because we can start the algorithm, then the magic happens, and what can we do with the output if it doesn't meet our limitations, which are many, many in the industry. So actually what we created is the tool which allows to assist the designer in this process, and between the points, just this is the simple beginning workflow, the shortest path is found. And how it happens here, particularly, it is like you click on some object in xeokit viewer, and then perpendicularly to its face, you can move the point just to determine the final or the first point of this segment of the piping. And for this interaction with the user, all the algorithms can be implemented. Here we have the example of the easiest one. It's simply X, Y, Z leading of the path. Okay, and we also used our outputs to show that we can do much more. So not only to use xeokit, but to use any software we need. Here, for example, we used our output path to show it in Aveva software, where some industries company have interest in simply to have their projects. So, but generally we can think about our software as a tool for any program. It could be useful for any plugin with this flexible architecture, and this is what we wanted to achieve. Okay, thank you very much.
Congrats, great presentation. So you have been minimizing the total length of the pipeline. And have you been thinking about other factors, such as the ease of installation, or what would the pipes be hanging from, etc.?
Yes, of course. At the beginning, we collected the list of different limitations that we can meet. And we decided in this short time simply to focus on the angle of the starting pipe, because it cannot go like parallelly to the wall, for example, even if it's in the allowable area. The also other limit was to, the constraint was, like the colleague showed, that we want to prefer some height. So for example, we want to lead the pipe just next to some supports where we can fix the piping.
Also, the first slide that was so fast, an interesting part was that that the input is AFC data, that we can get all the information from it, and also the penetration cost that we can estimate as weights. So almost every parameter that we can grab from IFC could be weighted. So for instance, IFC OpenShell has a possibility to raycasting elements from different points. So you can estimate the height to the nearest, the length, distance to the nearest wall, to the distance element. Then we can grab all the voxels as a weighted voxel map, voxels, agreed, and then parse it to the path algorithms. So it can be weighted as even as user experience. You can just slide the sliders.
Thank you.
So meant flexibly, but in this short time, what we showed.
But in the future, it can be more multi-criteria, basically.
Sure.
Okay, I think that was all. Thanks a lot. Good job.
Thank you very much.
Thank you for your presentation. Great job. Please. Thank you. Yes, and we are going slowly to the end. And the last but not least, please welcome Whistleblowers team. They need some stuff to be installed, so it will take a while. Surprise. Okay, taki będzie surprise. Yes. 5 minutes, very short outside. We have another surprise for you, and why should I announce? Simply say,
Musiał uciec, nie? Troszeczkę. Żebyś nie mógł siedzieć, tam nie siedział. Mógł się wypiermentrulić gdzieś? Możemy ci przestawić fotel, jeśli oczywiście o tym czekam jeszcze. Nie, jest dobrze. Jest dobrze. Ważne, żeby widowni nie było widać.
Hello, hello. Nie, to wystartujemy, jak będzie demo. Hello, everyone. We are the Whistleblowers team. Basically, Sygnaliści was the name in Polish that we went for. So we have tackled the challenge, intelligent EHS, environment, health and safety. And what we've decided to do is build a system that can use video recognition to identify basically hazards on the construction site. And the elements that we are going to show you is identification of people who are not wearing protective gear, who are basically having some accidents, like for example, falling person. We also have a non-online demo for identification of people entering the site, exiting the site. So that's basically what we went for, and that's the application that we've built. The application is actually online, cloud-based, but we will be talking about the architecture in a second. I think we can start with the presentation of the user experience that the person actually taking care of those accidents would be having. So maybe Philip.
All right, so first let me introduce you how you imagine that the system could look like for the operator who would interact with the service. So at the top of the platform, we can see that the system is able to catch some safety issues on the construction site, and also to detect how many people are currently on the construction site. As you can see, there are some camera pictures from the construction site if the system detects that there is some safety issue. We would also provide a different view that would also provide more detail for the person who would have to interact with the system. If the system detects some safety issue, the operator can see the picture from the camera, and it's up to them to decide if the alert is false or not. If it's not false, they click on the button to the alert, and the system will automatically send a notification to someone on the site who is responsible for the safety. And it will be including the time picture and which zone on the construction site the accident occurred, so they can act accordingly. Besides the safety alerts, we would also have a detection of how many people are currently on the construction site, and the system would be also able to detect how many, distinguish between different colors of the helmets, and based on that we would be able to tell what kind of people are on the site. And yeah.
Can you switch to Miro? Okay. So maybe I will get outside for those people over there, because I was sitting there before, I couldn't see anybody. So, yes, and I'm checking if anybody's there. We really need nobody to be there for our demo to work. So this is more or less of what we've built. I don't know if you can see it, but it's not maybe as pretty as the other diagrams, but this is actually a Miro board, and we've used it actually to develop our application over the last 48 hours, right? So there are a lot of green boxes that says done, which were actually not done, as we were working partially remotely, multiple people building different aspects of this application. We were actually synchronizing through this diagram that we created during the first night. And the important part for you is the yellow part on the left, where you have the camera, the detector module, and the alert panel, right? So the panel is actually the UI that Philip showed you. We will actually show it how we've built it. It's not as pretty, right? This is a hackathon. We had a limited amount of time. Also, our UI person is actually not a UI person and has used machine learning algorithms to actually generate the site. So it's wonderful. The camera module is actually over there. It will be collecting the data. The important element of this solution is that it doesn't require any specialized gear, right? So we're not detecting people by having wristbands or anything attached to their helmets. It's actually just image recognition using machine learning models available that we were able to find. Ultimately, we've settled for the model that Krzysztof found and optimized. We actually used the model available in the cloud originally, but it wasn't as good for us, so we've actually settled for on-prem model that's actually over there on the laptop. But the entire solution is actually pluggable and, I would say, online. So the situation is that we have a storage and an API that is actually hosted right now online, not within this Wi-Fi. You can actually access it publicly. Well, not publicly. You need an IPAK, it is secured and everything, right? But it can actually connect multiple sites, and that's important. So you can collect the data, the visual data from multiple sites. We actually stream the data, so the camera is actually sampling the data. So it's not I would say, not a constant stream. We're actually sampling the data with the screens. We're sending it to the cloud. We're storing it in the storage. And then we have a detector module that is actually constantly processing that data, feeding it to the machine learning algorithm, to the AI module, that actually identifies problems. And why that is good? Because you can actually, and you need to have specialized models for specialized threats. You can't have a model that will just identify everything, right? But with this approach, you can actually process the data in parallelly, but by multiple models to identify multiple threats. And then we have a third part, which is actually the UI, which is just displaying those, basically, screens that have been identified as problematic. Yeah? And we would love to show you how that works. Yes, so now we are in a wonderful situation when there is no alert, right? Nothing is happening wrong. I am starting the image capture from this device. Over here, Krzysztof is executing basically the processing model. And hopefully, in seconds, I am right now being recorded. I deliberately have the helmet on because I don't want to be displayed over here. But maybe rather than taking it off, I will invite Mateusz over here to join me. And I hope that everything will work and he will be identified as a potential threat on the construction site. I really hope so. If not, then he should be over there because we really had an issue. We could have tested before. The problem is really this large white screen over here. So if you need to be a problem, you should be here. Okay, yeah, hopefully will work. We've tested, as I said before, and I hope it will identify. No? Yes? But the resolution on this picture is maybe not perfect, but we have a no hard hat detection. But potentially the another thing we can do, which, because I promise I will even take off my helmet, and I hope I will be visible here, is what happens if I fall. And potentially, I really hope that this will work. Yes, now I've been detected as a fallen person. So that's literally what we wanted to show you, that this actually works, and it works online. Now you can make that decision whether you want to report. I know really not visible maybe, but there is report on the right and false report on the left, when you can actually online decide whether you should, well, basically notify somebody to do something about it, or somebody just needed to take a nap. So that's basically what we're doing over here. And that's pretty much it on the online demo, but we really wanted to also show you the actual real-life feed, because this is something we've managed to build by streaming over the internet, but we also have a more sophisticated solution, because on those pictures you actually can see the helmet, you actually can enhance those images with pinpointed visualization on what the problem is, and Krzysiek will show you that. Ja będę trzymał.
This model detects hello guys. This model detects no hard hat on workers' heads. Okay, I don't have hard hat. Yeah, and now I have hard hat, and this model can detect hard hat color. Yeah. And now it's white. Yeah? Yeah. But it's white. Okay. Maybe try this? Yeah? Or not? Okay, and
you can actually see single person with a hard hat.
Yeah. It's work. Okay, and second part of this code is fall detection. Okay.
Don't break it. We said nobody over there.
Ktoś przedstawia upadek?
The fall?
Yeah. And falling detection. Okay, and
so that's actually what we used for the online application, right? But with this, we can actually show you the exact problem that happened, right? We didn't have time really to put those boxes on the online view, so we just wanted to show you how precise it's actually finding those incidents. Czy chciałeś to wejścia, wyjścia? Na filmiku, czy...
Okay, this model recognizes how many people is on construction site. This is very simple model because people on screen are around by a rectangle, and on the center point of this rectangle we have yes, we can check trajectory of this point, and when this point cross the red line first, and in the next time cross the blue line, we know the worker or the people go inside to construction site. Okay, thank you.
And this is actually also implemented, so we stream this value directly to the dashboard. Maybe the last thing is this extensibility, which Grzesiek mentioned. It was kind of important for us because, you know, as Grzesiek said, not all models fit all our purpose, and we could play a bit with OpenAI models to have a role as someone who verify all these cases. So, so there is a lot of possibility to, you know, verify the output of the AI by another AI, which is quite powerful. Yeah.
Questions?
So you could verify the AI by another AI, but at the end there would be a human being just checking whether this incident is actually an incident or not.
We assume there should be, but there is nothing really preventing you if you have a model well trained enough or you believe it, right? I wouldn't roll this out in the first instance to call ambulance immediately on every recognition, right? But I assume in the future that's exactly what's going to happen. So yes, when we have very well pinpointed algorithms or models for specific cases, I don't think there will be the need for verification.
Because if there is a verifier, then that can be also an input to training another model, or just building on top of an existing trained models.
That's exactly it. The first step would be, okay, I don't want to go there, but that's exactly what I've did in the past. You generate the data, and then you learn on the verification of the data. So yes, of course, the false alarm is an important learning input for making our model even better.
Great job, thanks.
Thanks for a great presentation. And my question is, did you consider any other ideas for fall detection? Because if you have a camera, you cannot have a camera on every where on a construction site. So probably it's not a best device for this. So did you have any idea how to manage this?
Yeah, we had a discussion. There are solutions which you can mount on the helmet, which will send the signal. Of course, you can expand this solution using different devices. There's plenty. But my idea, our idea was here to start from things simple, and then where seeing all the deficit, we can improve by adding new devices. This is also very cost effective. You don't need any extra equipment. You have most likely on all the sides cameras. Whole solution is quite simple. All the models are open source, so you can start from something and then build on top of that to fit all your special needs.
Okay, and could you elaborate more about challenges, like for example, where there is two people trying to go on site? This is one rectangle, for example, or if you have a bald head or silver hair. So do you have more that kind of problems?
Of course. So I can give a couple of examples, maybe context, right? Mateusz used to work for retail with actual shops. So, for example, a detection of people behaving strangely or trying to steal stuff is something that we had experience with. The other experience would be, for example, the area where you have like stadiums and people are entering them and actually managing where they go in. There's a software that we know about, et cetera, right? I assume that you really shouldn't allow people to enter your construction sites through 10-meter wide entrance just in a groups, right? I assume that there are other methods of identification. So from that perspective, if you have certain rules of entering the area, this kind of removes the problems, right? So we're not saying this solves every problem. I wouldn't count protesters in Warsaw based on this, that people still would not agree how many of them were there. But on the construction site, I think this would be suitable.
And there are another simple solution for that. You can have a different camera perspective, so you can double check the same results. So yeah, the possibility here are to deal with such a problems. Any more questions?
Oh, thank you.
Musimy wyjść, zrobić zdjęcie.
Thank you for such an amazing presentation. Really impressed. Picture. Thank you very much. Within our plan, it was the last presentation, but because the flexibility and openness is our DNA, so we have one more presenter. So please welcome Michał. Proszę. Podłącz się, proszę. Okay. About the something like this.
Hello, I'm Michał. It's a pleasure to present to you. And well, I'm sorry I didn't register for this earlier, but I actually had this idea while coming here on a tram in the morning, and I decided to hack it quickly in these 3 or 4 hours that we had. So basically, this is a piece of building code in Poland. If you're an AEC practitioner, probably you know it, with the beautiful name. Rozporządzenie w sprawie warunków technicznych, którym powinny odpowiadać budynki oraz ich usytuowanie, or in short, warunki techniczne. It's a big boy, 100 of pages, and you most often have to look up some information in it. And the most obvious way to do it is, of course, to do the good old Control F or Command F, not the most high-tech solution. The next option would be to use one of those websites, which are more interactive. Maybe there is a table of contents, and you can click on one of those chapters. Sometimes it works, sometimes it doesn't. For me, for example, this is what happens. So this is all fine unless you are new to the subject, or perhaps you are not a professional, you are just a person who wants to develop their land and are curious about the building code and how they can operate within this legal framework. So I could say that the whole value proposition of this project is basically this. So yes, there is the Control F of the PDF, there is the interactive website, and what I'm proposing is to chat with the document using your natural language, and I will show a demo of that. now. So first, I will start the app. Okay, so this is the beautiful UI that I managed to patch together in 5 minutes. Okay, this is better. So you can see I'm sorry it's in Polish because the document is in Polish. So the chat is asking you, hello, how can I help you today? And you are able to prompt it with a question in natural language about the building code. So I have some prompts prepared here. So the first question is, how far can I build a building which can explode from the edge of the forest? A little bit random, but in fact it's a piece of the code. And the chat tells us that if it's a building that is built of elements that don't actually that self-extinguish, it has to be at least 4 meters from the forest edge. If the forest is on a separate plot, if it's not on a separate plot, then it doesn't really matter. And it's also giving us some sources to the section, to the chapter and the paragraph, so you can look it up. Let's try another one. So this one is interesting because I'm asking how wide should let me scroll this down. How wide should a fire emergency exit be in a 200 capacity lecture hall, for example? And it's not directly mentioned in the document anyway. There is a formula for that. And the chat was smart enough to actually calculate it. So the formula says that it's 0.6 meters per 100 people. And it tells us that it should be 1.2 meters for this specific capacity. And it's also saying that either way, the minimum has to be 90 centimeters. Again, with the sources. And since it's kind of working, I would love to have a question from the audience. If there is someone who would like to have a question to warunki techniczne that I could ask the chat, and we'll see together what happens. Yes? 201 osób. Okay, let's try. So it's about asking not for 200 people, but 201. So I'm just changing 200 to 201. I'm really curious what will happen. So the fire, that's a great one. So it used the formula, yeah, but it calculated that the fire escape has to be 1.2 meters and 6 millimeters. So this is probably not what the legislator of Poland had in mind, but maybe we should ask a legal professional whether this is a correct interpretation of law or not. Anything else? Okay. I mean, yeah, I just wanted to ask because I prepared some of these questions, but yeah, we can try with each other. And at this point, of course, you would click on one of the sources and it would show up. Now we only have to revert to good old Control F. So thank you so much. Maybe it's not so groundbreaking, but I really hope it's actually useful for people who have to deal with these legal documents every day. Thank you. Okay, sorry. But yes.
Thank you very much. Thank you. That's the last presentation. Thank you. All the presentation was really amazing. Big applause for all the presenters. Now our jury will go for a deliberation process. So let's give them 1 hour to evaluate your projects, and we will meet here. What time is it? Oh, I lost. It was so interesting. Yeah, it is 3:45, so half an hour. Yeah, let's meet 4:15 here on the winning awards ceremony. Of course, in the meantime, feel free to build the networking and to get some refreshments, and see you 4:15.